Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology. Subject code CS8602, Compiler Design, Unit 3, Topic Intermediate Languages, Syntax Tree. Intermediate languages. In the analysis synthesis model of a compiler, the front end analyzes a source program and creates an intermediate representation from which the back end generates target code. Here, ideally, the details of the source language are confined to the front end and details of the target machine to the back end. Although a source program can be translated directly into the target language, some benefits of using a machine independent intermediate format are intermediate formats are retargeting is facilitated. A compiler for a different machine can be created by attacking a backend for the new machine to an existing foreign data. Then the machine independent code optimizer can be applied to an intermediate representation. That means a well-defined intermediate representation, a compiler for language I and machine J can be built by combining the front end of the language I with the back end for machine J. Here in the diagram it shows the logical structure of a compiler front end. In the front end you have the parser, static checker, intermediate code generator. In the back end you have the code generator. A static checking means it includes type checking. It ensures that operators are applied to compatible operands. It also includes any syntactic checks that remains after passing. It assures that a break statement in C is enclosed within a while, for, or switch statement. An error is reported if such an enclosing statement does not exist. In this process of translating a program in a given source language into code for a given target machine. The next one is syntax tree. Three kinds. Here a syntax tree depicts the natural hierarchical structure of a source program. A tag gives the same information but in more compact way because common sub expressions are identified. A syntax tree and tag for the assignment statement A equal to B into minus C plus B into minus C. Here the assignment statement is come under the interior node, and then terminal symbols come under the leaf child, and then operator symbol also come under the interior node. It is a linearized representation of a syntax tree. It is a list of the node of the tree in which a node appears immediately after its children. The postfix notation for the syntax tree is shown in the above graph, that is ABC U minus into BC U minus into plus assign. Variants of syntax tree. Nodes in a syntax tree represent constructs in the source program. The children of a node represent the meaningful components of a construct. Here DAG means it's a directed acyclic graph for an expression, identifies the common sub-expression of the expression. The next one is directed acyclic graph expression. Here the syntax tree for an expression has leaves corresponding to atomic operands and interior cores corresponding to the operators. The difference is that a node n in a DAG has more than one parent if n represents a common sub-expression, and in a syntax tree the tree for the common sub-expressions would be replicated as many times as the sub-expression appears in the original expression. Thus a DAG not only represents expression more succinctly, it gives the compiler important clues regarding the generation of efficient code to evaluate the expressions. For the DAG, we have one C. The example A plus A into B minus C plus B minus C into D. Here B minus C is the common for, so the plus symbol take it as a 2 times. This is the example for directed acyclic graph. Thank you.